today we are going to introduce what a polynomial is. So in our notes, we are going to be on pages 9 and 10. Okay, so we are just going to talk about what a polynomial is today. We're going to talk about what is and what isn't, and then classify them. So the word polynomial is made up of two words. It's made up of poly. Poly means many. And nomial, which means terms or parts. Okay, so its literal meaning, a polynomial means many parts or many terms. In the table below, we'll discuss more specifically what makes something a polynomial and the way we can also describe a polynomial later. So a polynomial is an expression with one or more algebraic terms. So we're just talking about math problems. We're not doing equal signs right now. They're just math problems. So a polynomial can include constants. So constants are just regular numbers, no variables attached to them, just three regular numbers. Variables like x and y, and whole number exponents. Okay. A polynomial cannot include division by a variable. Okay. And because of that, negative exponents would then make it a division of a variable, so negative exponents are also not classified as polynomials. All right, so the first thing we're going to do is, based on this definition, we're going to sort each of these expressions on whether we think they represent polynomials or not. If they don't, we are going to justify why we think it's not. Okay, so A, this very first one, we have 12x to the negative third, okay? And right now it has a negative exponent. If we were to simplify that using positive exponents, we would have to move it to the denominator. And then we would be dividing by a variable. And because of that, this makes it not a polynomial. It's not classified as a polynomial. The reason you could say that is there is a negative exponent. Okay. Or you could say it's not a whole number exponent. Okay. B, we have 6xy to the fifth minus 2x to the third plus 4. We just have a bunch of math problems. They include numbers, variables, and whole number exponents. So this would be a polynomial, many-parted expression. All right, number C, we have negative 3x plus x divided by y minus 11y. And so right here, I see a fraction. And in that fraction, in that denominator, we're dividing by a variable, which makes this not a polynomial. So C is also not a polynomial, and that would be because we are dividing by a variable. All right. D, 5x to the second minus 1.2x plus 3. This looks very just standard. It has numbers and variables and positive exponents. Okay, so it is a polynomial. And E, we have 9 plus x all divided by 2. And this is actually a polynomial because we're not dividing by a variable. We're dividing by a number that we know. So this would also be classified as a polynomial. Okay. So we have polynomials, and now we'll talk about the degree of the polynomial and how we can classify them. So the degree of a polynomial is the highest exponent of any of the terms or parts in a polynomial. So what is the highest exponent in a expression? That would be the degree of that polynomial. The standard form of a polynomial would be putting the terms in descending order based on the degree of the term. Okay? In this form, when something's in standard form, the coefficient of the first term is called our leading coefficient. So this has a lot of vocabulary in today's lesson. Okay, so we have all of these parts to an expression, and we're going to dissect it and understand the parts of it. So we have 3x to the second plus 4x minus 7, okay? So this is an expression. This is a polynomial, okay? These three parts are our terms, okay? this right here is our highest exponent variable. Okay, so this is our degree. So this is a degree 2 polynomial. Okay. The coefficient, which is the number in front of this highest degree variable, is called the leading coefficient. And then finally, any numbers that have no variables are just called constants. Okay. So now what we're going to do is we're just going to practice rewriting polynomials in standard form, which means going from highest to lowest, and then identifying what degree of that polynomial is. Okay, so we have 15 plus 4x to the fifth plus 7x to the second. I see the highest exponent being an x to the fifth, so we are going to start off with 4x to the fifth. Okay. The next highest exponent I see is a 2, so we're going to put that one next. 7x to the second. Okay. And our final one is just 15, so we'll put 15 last. So in standard form, this is just rewritten as 4x to the fifth plus 7x squared plus 15. The degree is the exponent, and so this is a degree 5 polynomial. All right, number 2, we look for the highest exponent. I see an exponent of a 4. So in standard form, our leading coefficient is 2x to the fourth. And the next one, I see 5x to the third. Next, I see negative 10x. And then I see a minus 13 finally. Okay, so we end with any constants if we have any. Then the highest degree of this polynomial is degree 4. Okay, now we're gonna be on page 10, I believe, and we are gonna start classifying polynomials. Because based off the degree, we can call them certain things. So a polynomial is classified by the number of terms or parts it has in its most simplified form. Okay, so if we have a problem like a polynomial that has one term, which means one part, for example, this could just be 5x to the second. Okay, this has one term, so we call that a monomial. Okay, mon means one. Okay, then if it has two terms, like maybe 5x to the second plus 3x. Okay, there's two parts to it, so we call that a binomial. Okay. Finally, we have if something is three terms, something like 5x to the second plus 3x minus 1. There's three parts to it. We call that a trinomial. Okay. Then finally, if there's anything that is 3 or if there's anything more than 3, we just call it just simply a polynomial. Okay. In Algebra 1, we spend a lot of time talking about trinomials and binomials, so that's why we're just talking about how we can just classify them as trinomials specifically. Okay. So first, we are going to decide if these expressions are polynomials. If they are, we're going to identify the degree at which they are, and then we'll classify them as monomial, binomial, or trinomial. Okay, so this first one, okay, I see all positive exponents. I see no division of variables, so this is a polynomial. Okay, the degree is the highest exponent, so the highest exponent I see is a 2, so this is a degree 2 polynomial. And specifically, there's 1, 2, 3 parts to this math problem, so it can be classified as a trinomial. Okay, this one right here, x to the negative fifth plus 14. We see this negative exponent, so we can stop right there because we cannot do negative exponents. So this is not a polynomial, so it does not have a degree, and it cannot be classified as anything. Okay, this next one, we have x minus 2. This is technically a polynomial. Okay. For its degree, we have to find the highest exponent. So this would be a degree 1 because I see a 1 variable, so it could have an imaginary 1. Okay. And when I think about the classification, there's 2 parts to this. We have an x and a -2, so this would be considered a binomial. Okay. This one right here, we have just a constant. Constants are technically considered polynomials. It is just a number, so it is just a very basic polynomial. It would be a degree 0, right? Because we don't have any variables. Right? And then there's 1 part to it, so we would call that a monomial. Okay. All right, and then this final one, we have x to the 7 plus 5, all divided by x. Dividing by x nixes the idea of a polynomial, so we can stop right there. Okay. Algebra tiles can be very helpful when visualizing and working with polynomials, and we'll kind of use that while we're doing this rest of this unit. In problems 3 and 4, we're going to list the polynomials represented by the tiles, or we'll sketch it using the pictures. Okay, so I see x squareds, so I see squares. Okay, I see x bars, and then I see little ones. Okay, so I see a total of 3x squareds. Okay. I see 2 negative x's, and I see a positive x. So this would make a 0 pair. So then I'm just left with 1 negative x. Okay. Then I see a bunch of 1s. I see 4 1s and 2 negative 1s. So that would make a 0 pair. That would make a 0 pair. I'm left with 2 1s. So simplified, that would be 3x squared minus x plus 2. All right. If they ask us to draw a picture of this, to draw negative 2x squareds, so I'm going to make some squares. I'm going to say negative x squared. I'm going to make 2 of them. Okay. Then we have 1 x bar, so I'm just going to draw a little x bar. Right? And then we have negative 3 1s. Okay. So that's how we could draw, just to visualize that these are 3 different things. Okay. Last problems. Mateo wrote a binomial on the board. Okay. Labeled each statement as true or false. So I'm going to first remember binomial means 2. Okay. Mateo's expression must have a degree of 2. Remember, degree means the exponent, the highest exponent. Okay. And I'm going to go ahead and say that's false because I could think of a problem like x plus 2, which has 2 terms. It's technically a binomial. But if I think about the degree, this just has a degree 1 polynomial. Okay. Mateo's expression must have a coefficient of 2. Okay. I'm going to say that's also false just by coming up with an example of using this example as well. This is a binomial, and the coefficient would be a coefficient of 1. I could also put any other number in front of it. It would still be a binomial. Okay. Mateo's expression must have 2 terms. I think that's the only one that is right because binomial means 2, and that is literally the only thing that we can assume. Okay. Number 6, fill in the blank with sometimes, always, or never in order to make the statement true. Okay. A polynomial will blank include an exponent. Okay. So a lot of the times polynomials do include exponents, but that does not necessarily mean it always has to. Like this example right here, if I erase the exponent of a 1, this is still considered a polynomial, but there's no real exponents to it. Also, regular constants are considered a polynomial. So while it most of the time at this point it will, that we cannot assume it always will. So sometimes it'll include an exponent, but it doesn't always. Okay. A polynomial will blank include a division of a variable. So if we think about a polynomial, the only thing it can't have is negative exponents or division of a variable. So polynomials will never include a division of a variable. Okay. And then finally, a polynomial will blank have more than 1 term. Okay. And this one is also sometimes. kind of hard to, it's weird to think about, but this is technically, 8 is technically a polynomial. And then we could always add extra terms to it and make it bigger, like a binomial or a trinomial, but 8 is still a standalone one-term polynomial. Okay, so for today, guys, you guys are going to practice page 11.